In this podcast, we're going to be looking at the unit for power. Okay, we've been talking about kinetic energy and potential energy. Now, power is just another system that goes along with kinetic energy, potential energy, and work. Power is the time rate at which we are doing work. Again, we can calculate work by taking the force times distance. So if we're looking at the time that we have applied this force over a distance, that is what our power is. So work divided by time is how we find power. And again, work is force times distance, so force times distance divided by time. The SI units for power, for work it's the joule, for time it's the second. So when we combine these two, joules per second, we get watts. Okay, a watt is something that you're probably familiar with because that is how we look at the power output of a light bulb. It's how many watts. So for example, a 100-watt light bulb uses 100 joules per second of electrical energy, or 100 watts. Typically, your lights in your lamps in your living rooms are anywhere between 40, 60, 80, possibly 100, 120. Probably your light bulbs in your lamps aren't going to get any bigger than that. So be careful not to confuse the W with work with the W with watt. Okay, so this particular example is showing that the force of 1 Newton to raise a mass of 1 meter, the amount of work that is being done is 1 joule, because force is mass over a distance. So looking at this example, if the work is done in 1 second, we should be able to calculate the distance. So the distance here that it's showing in the picture is 1 meter. So we have force times 1. Force is 1 because we have a mass. A force equals mass times distance. So mass of 1, distance of 1, force equals 1. So work equals the force times the distance. We have that 1 joule of work. If it's done in 1 second, 1 joule of work divided by 1 second is our 1 watt. So here are some different units that we've been dealing with. Force is measured in newtons. Newtons is equivalent to the kilogram per meter per second squared because we're dealing with mass and acceleration. Work is the joule. That is the newton and the meter because it's force divided by distance, or excuse me, force times distance. Energy. Energy is also the joule. Same equivalent unit. Now power is the watt, joules per second. Now the British system, like we've said before, it works with work. It says the foot-pound. Now we're also going to introduce the horsepower. You might have heard of horsepower as in how much power a car may have. Has this many horsepowers, or how much a lawnmower may have. It's commonly used unit for power in the British system. However, we do use it here in the United States. 1 horsepower equals 746 watts. Typically, a horsepower is a lot of energy that's being used. The greater the power of an engine, the faster it can do work. A 2 horsepower engine can do twice as much work as a 1 horsepower engine in the same amount of time. A 3 horsepower engine can do 3 times as much work in the same amount of time as 1 horsepower. Okay, so we're going to use the power formula to solve these examples. Go ahead and put it right on your notes this time. A constant force of 150 newtons is pushed a stalled motorcycle 10 meters along a flat road in 20 seconds. Calculate the power expended in watts. Okay, so some things that we know. We know that the force is 150 newtons. The distance traveled is 10 meters, and the time that it's allocated in is 20 seconds. So if we're trying to find power, remember power is taking work divided by time. In this particular example, it doesn't calculate work for us. However, it does give us force times distance, which is work. Okay, so we're going to take that 150 newtons, multiply by our 10 meters, and then take that and divide by 20, and we get 75 watts. Again, with this podcast, if I'm going too quickly, just go ahead and pause it, write down what you need, and then push play again. All right, a second example. A student expends 7.5 watts of power in lifting a textbook 0.5 meters in 1 second. How much work is done, and how much does the book weigh in newtons? Okay, so we're looking for weight here. So a couple things. We're given power, 7.5 watts. We're given a distance of 0.5 meters, and we're also getting a time period of 1 second. Okay, so make sure we know the difference. Capital W, we're going to look at as work. Lowercase w is going to be weight. Okay, so the work is power in a certain amount of time. So they give us power at 7.5 watts. The time they give us is 1 second. Now this particular formula, I rearranged the power formula, which is work divided by time, so therefore work is power times time. So we have 7.5 joules per second in 1 second. So that would be 7.5 joules. So that is our work. So remember that weight is a force. Weight equals force times distance. So when we have a force, we take the weight divided by the distance. So if force, or the weight, in this problem, is 7.5 joules, divide that by 0.5 meters, and we get 15 newtons. Again, if the podcast is going too fast, go ahead and pause it, rewind it, kind of reread over it, and go at your own pace. So the work done is 7.5 joules, and the book weighs 15 newtons. We can also find electrical energy as well. To find electrical energy, we take the energy produced or consumed divided by the time. So instead of saying work, remember work is an energy. The power formula is work divided by time, so we can replace that with an E and say energy divided by time. So in this case, rearranging the formula, energy equals power times time. So joules are the units that we use for work and energy. The bigger unit of power, so if we're looking at the amount of energy per hour, we would say kilowatt per hour. Usually when they're measuring your electricity to figure out how much electricity you've used in a month, they would say kilowatt per hour. A 1 horsepower electric motor runs for 10 hours. How much energy is consumed in kilowatts per hour? So our power they give us is 1 horsepower. The time they give us is 10 hours. Find energy. Energy in kilowatts per hour. So we're going to convert the power from horsepower to watts to kilowatts. So if 1 horsepower equals 746 watts, I'm going to convert that into kilowatts. Kilo is 1,000, so we multiply by 1 over 1,000 or divide by 1,000. Or King Henry does usually drink chocolate milk. Watt is a base unit. Move that decimal place 3 places to the left. So we have 0.746 kilowatts. We're going to use that as our power. So looking at the energy formula, energy equals power times time, 0.75 kilowatts times 10 hours, we get 7.5 kilowatts per hour. Now just remember, no matter what type of energy that we are speaking of, chemical, electrical, mechanical, the main unifying concept is that energy is conserved. We cannot create energy, we cannot destroy it, but we can change it from one form to another. So we've been talking about work and energy and how work and energy are the same. They're just different forms of energy. They are conserved. We can use work to find our power that we've been talking about in this podcast. Power equals work in a certain amount of time. So we need to have that energy component. And so that energy is being conserved. So that concludes the podcast over power.